So behavioral economics and judgment decision making, lots of books. And what's interesting to me about this whole thing is that we're typically, when we have podcasts or TED Talks, or we write these kinds of books to the public, we give others advice. Sometimes companies come to me, nonprofits come to me, the government comes to me and they say, can you please tell us how to do better investment, how to do better policy? The thing is that most of the time, academics are just very, very poor, very, very good at giving others advice, but they're very, very poor at implementing their own advice on themselves, which is very, very odd. Why don't you first learn what is it that you know about yourself, improve yourself, then go to others and tell them what to do? Yeah. So this is kind of like the main theme of today's talk. Before I tell you what to do in your life and how to improve your financial decision making and your happiness and all of that, first I want to tell you that I really care about checking myself, whether I am biased, whether there's something about the way that I do science that doesn't work. Okay. So we'll start with a Mentimeter, just an exercise for you. So you've got this here to scan if you want. And this is the question I have for you. So let's say I have three numbers. I'm going to tell you the series of numbers. In this case, it's 2, 4, and 8. And 2, 4, and 8 follow some kind of rule. But I'm not going to tell you the rule. I want you to figure out by yourself what the rule is. Okay? Now, the way for you to figure out is to ask me by giving me a list of a new three numbers and asking me, does this obey or not obey your rule? And then I will tell you, yes, obeys my rule, or no, does not obey my rule. Then I will ask you to guess what the rule is, okay? So my question to you is, what three numbers should you ask me? Okay, so I'll give you a moment, take a moment, think. Right now, the numbers that you have are 2, 4, and 8. In addition, while you're thinking about what numbers to ask me, I want you to put your scientist hat on and think, what is it trying to do? You've already done very well last week. You've expected in advance, anticipated, predicted what I'm going to ask, and you answered a different way. Very good. Let's do this now as well, okay? So try and predict in advance, why is he asking us this? What is this supposed to demonstrate? Okay? Good, so we have 4 answers. Take some time, think about this. 2, 4, 8. I have a rule. You can suggest 3 new numbers, and then I will tell you if this obeys or not, and then ask you what the rule is, okay? Yeah, take a moment. Good, 9, 10. Terrific. Okay, so before I show you everybody's response, who wants to play with me? Who wants to guess? I need 3 numbers. Anybody? Yes, please. 136 obeys my rule. What do you think the rule is? Perfect. That is a really good guess, but this is not my rule. Thank you very much for playing. Great. So we've learned something. We have a new piece of evidence, right? So she has tried something, and then she got another piece of information, but she did not guess my rule, right? Who else wants to try? 9112. 9112 does not follow my rule. Thank you. Very good guess. Why did you guess that one? Okay. Very good. Yes. 468 obeys my rule. Yes. What is your guess about my rule? She already had a guess. I did not respond. All even numbers. Very good. Very good. Now, this was a very interesting approach because what you did is actually a little bit counterintuitive. Right? Most of the people, when asked to predict, look for something that is confirming. So there's something here, there's like a pattern. So most people think, oh, it doubles every time, 2, 4, 8, right? And then a lot of people just do the same kind of thing rather than looking for disconfirming evidence, right? So there's a very big, you'll see me using a lot of influencers and YouTubers. There's a very big and solid YouTuber. We're going to refer to him a lot in this course, at least twice today, because he does some amazing stuff. His name is Veritasium. Do you know him? Who knows Veritasium? No? Worth following, at least 2 million followers on YouTube. I'm going to show you a video where he does this kind of trick. Just before this, let's see the stuff that you wrote. So we have 16, 32, 64. What does this do? Looks at whether it's doubling, right? And it's increasing. So this definitely follows the rule, but it just tries to confirm by doing something that's very similar to the pattern of numbers from before. We see here happening again. So as you can see, this doubles, this doubles. Very few people, students, are trying to do the disconfirming sort of thing, 9, 1, 12, right? So very interesting just how many 16, 32, 64, 16, 32, 64, right? So very, very interesting to do this. How many disconfirming do you have over here? You've got like with the 111. This is again trying to do the doubling one. This is an interesting attempt because it looks at the negative side of this, right? Again, we've got the 16, 32, 64. What is it about the 16, 32, 64? Very interesting, right? So we can see that as a population, there is some tendency for most people to follow a certain path. But is this the right path in order to find out what my rule is, okay? So this is adopted from a YouTube video. I'll show you the YouTube video.
I'm going to give you guys three numbers, a three-number sequence, and I have a rule in mind that these three numbers obey. And I want you to try to figure out what that rule is. But the way that you can get information is by proposing your own set of three numbers, to which I will say, yes, that follows my rule, or no, it doesn't follow my rule, and then you can propose what you think the rule is. Is that fair?
Yeah.
Yeah. Okay, so here are the three numbers, 2, 4, 8.
2, 4, 8.
You don't need to continue the sequence. You can propose a totally different sequence, whatever you want to propose, and I will simply say yes or no, that follows my rule.
2, 4, 8. 16, 32.
16, 32, and
64.
64.
Amazing, no?
those also follow my rule.
A magic
Okay.
trick.
What's the rule? What do you think?
Multiply by 2.
That is not my rule.
What?
That's not my rule. But you're allowed, if you want, propose three other numbers.
3, 6, 12.
3, 6, 12.
3, 6, 12
Amazing. We've
follows my rule.
6, 12.
10, 20, 40.
10, 20, 40.
That follows the rule.
Yeah, I'm still multiplying by 2.
I know. I know what you're doing. And yes, it follows my rule, but no, it's not my rule.
5, 10,
10 and 20.
Follows my rule.
100,
200, 400.
Follows my rule.
500, 1,000, 2,000.
Follows my rule.
Want me to keep going?
But do I just keep going? You're going to tell me your rule?
Am I doing it the wrong way? Am I approaching this the wrong way?
You're totally fine,
Okay.
but you're approaching it the way most people approach it. Like, think strategically about this. You want information.
Yeah.
I have information. The point of the three numbers, right, is to allow you to figure out what the rule is.
Okay.
Okay, I'm going to give you the numbers that I don't think fits the sequence and then see what you say. So I'll say 2, 4, 7.
Fits my rule.
So whatever I propose is right?
So is your rule like you can propose any number?
So the rule is anything we say is yes.
No.
Damn it.
But you are on the right track now. Hit me with three numbers.
3, 6, 9.
Follows my rule.
Oh, that didn't follow my rule.
This is good, right?
5, 10, 15.
That follows my rule.
What? Oh. Really?
Yeah.
I don't believe this.
1, 2, 3.
1, 2, 3.
Follows the rule.
What about 7, 8, 9?
Follows. Yes, that follows the rule.
8, 16, 39.
Fits the rule.
Excellent.
But we're no closer to the rule. I want you to get to the rule. How about 1, 7, 13? Follows the rule.
What?
11, 12, 13.
How does this
follows
make
the
sense?
rule. 10,
I don't know
9,
how to
8.
do this.
Does not follow the rule. 10, 9, 8 does not.
Oh, so is it all in ascending order?
Booyah.
Okay.
Up top. Yes, first
that
ones
what
to
it
get
is?
it. You guys nailed it. That's the rule. That's the rule. Increase numbers in increasing order. Numbers in ascending order.
Oh, so much.
1, 2, 3, 4, 5, 6, 10, 15, 25. Doesn't matter. Any numbers in ascending order. I was inspired to make this video by the book The Black Swan by Nassim Taleb. Now, the black swan is a metaphor for the unknown and the unexpected. I mean, in the old world, the theory was that all swans were white. So each instance of a white swan would make you think, yeah, that theory's pretty good. But the point is, you can never prove a theory true. And in fact, when people found Australia, they realized that there were black swans. What was interesting for me was that everyone I spoke to came up with a rule very early on and then only proposed numbers that fit with that rule they were thinking. I was looking for you guys to propose a set of numbers that didn't follow your rule and didn't follow my rule. I was looking for you guys not to try to confirm what you believe.
Yeah, what I like about this guy, aside from him being very charming, is that he's able to communicate things very, very clearly. So actually, this is a classic study that was done in the 1970s. And we use this in some of our research when we run empirical lab studies. It's called the Watson task. So I'm going to ask you here again, now that you know what the trick is. So I'm going to return to this. And this is the Watson task, so I'll give you a chance to go through this. This is what we have. We have 4 cards. Each card has a number on one side and a patch of color on the other. Now you're asked to test the hypothesis that for these 4 cards, if an even number appears on one side, then the opposite side is red. Now you know how confirmation bias works. We have the tendency to want to confirm something. So look at these 4 cards and think for a second, which ones do you need to turn in order to find the right answer? Which gives you the most information? Which ones are critical, crucial, and which ones are not? So we've got an odd number, we've got an even number, we've got one with a red color on the side, and then we've got an orange color on the side. Which card or cards should you turn over in order to test this hypothesis? And now that you know how this works, also put the scientist hat on and tell me, what would most people say? If Veritasium is going to go around in the park, giving the Watson tasks to people, what are they going to say? Okay, good, 6, 7, think about it. Take your time. All right, good. So let me ask you before I show you the result here, whether we got this right or not, whether we've learned something from Veritasium or not. What would most people say? Before we say what the right answer is, what would most people say? What seems like the obvious almost trap here? All right. Card B, yeah, what is it about card B? Good. So the nice thing about B, so B definitely is a nice card to choose because it seems like it would follow the pattern. So it has the ability to confirm the hypothesis. But card B is a very special card because it has another ability. It can also disconfirm, right? So if we don't find what we expect afterwards, that's also disconfirming. So actually, card B is pretty solid. It's a solid choice. However, there's another card that most people would go for that maybe does not give this amount of information. Which one would that be? Which one is the trap? C, yeah, good. All right, so you're getting this. So why is C the trap? What is it about the C? Because it's already turned to the color side, right? So whatever is going to happen when we turn this around, if we see an even number or an odd number, is this going to give us important information? It is not, but this is a trap. Because people see, oh, red, somewhere here in the question is a red, therefore I'll go for that, right? But if you take a moment to think about this longer, and these people had a lot of time to consider any other kind of 3 numbers, right? But they got stuck in a pattern. So immediately we use shortcuts. This is what Kahneman and Tversky call heuristics. We have mental shortcuts that kind of lead us into C. So some of the shortcuts are good, are very solid. We choose B. It's confirming, but it also has the ability to disconfirm. But sometimes mental shortcuts, heuristics, lead us into something that does not help us, like C. However, there is an option here that most people will not choose, but actually offers a lot of information. Which one is that? And I think this is the stuff that most people don't get right, yes? Option D, yes? Exactly, very, very good. So if we turn around D, it is an even number, then we've got something disconfirming, right? But most people don't go for that. It's very counterintuitive. To be able to do the 7 to 9, 1, 12, it's very counterintuitive. Most people, so when I first looked at this, I got this wrong, right? So if we look at what most people answered here, see card D, okay, you got this. Yeah, very good. Card D definitely does the trick. Card B does the trick, but card C and card A do not do the trick. Yeah. So you've learned something from the previous one. I just want to show you the original findings. So the typical responses and what we see in the Watson response when we give this to people since the 1970s is that many people choose B and C. They believe that this is the most critical, but actually D is critical and C is not. Okay. Now, the classic study by Mahoney in 1976 reviewed scientists. We're talking about people here at HKU, professors with degrees, statistician conferences. They go around and they give them the Watson task and they ask them which ones are the critical ones. So fewer than 10% correctly identified the critical card, which is amazing. And sometimes as fun, when I go around the world and I give workshops to people, I give this to scientists, I give this to PhDs, to postdoc, assistant professor, full professors, journal editors. It's amazing to see how many people get this wrong. They haven't seen Veritasium before they were confronted with this. This is the first one that I give them. And they think it's very, very obvious. Why are you even showing this to us? Of course it's B and C. And then, okay, take a moment, think about this very carefully for each card. And then when they take a moment and they switch on the deliberation mode, that needs more systematic processing, then they're like, oh, wait, C doesn't really lead to the answer. But okay, now D, when I think about it, D is the right one. So it's not that we're not able to know what the answer is. We are able to know what the answer is, but mental shortcuts, heuristics, lead us sometimes in the wrong direction, okay? We call this, and we've known about this for a very long time, we call this confirmation bias. So what could be a demonstration of confirmation bias when it comes to misinformation and social media and the news? How can you apply this to what's happening in everyday life? Where do we see confirmation bias? Where do you observe confirmation bias in your everyday life? Please, yes. Social media, give me an example. What do you see?
Let's say they have an article or they won't look at other articles. Not like that. So they'll just like each movie. Like this is Sky's Red. Sorry.
Sky's Red. Yes. Very good. Very good. Sky's Red is a very good example. Actually, it's as an exercise. Just do this maybe in incognito mode. Go to YouTube and search, is the Earth flat? Just as an exercise and see what happens. Oh my God, there are so many videos with scientific evidence about Earth being flat. And then there's a big conspiracy theory that everybody is involved. You know, the government, pilots in the planes that fool you as if they're going around the world, but they're not. They're just flying on a straight plane, right? But rather than looking for more information to support what you think is already true, right? Then also look for information to disconfirm what you think is true. Then there's a whole other question about how do you know whether the YouTube video presents the right evidence, even if they're presenting scientific evidence, is this true or not? So one big example, I think we're all worried about this, is climate change. Is climate change real or not real, right? So if you go to YouTube in incognito mode and just look for, is climate change fake? Just see, like, an never-ending series of YouTube videos that will help you convince yourself that climate change is a hoax, that it's completely fake. However, you want both sides. But then, do both sides have the same kind of merit? 99.99% of scientists think that the evidence for climate change is very, very solid. There is the small minority, and they could be very, very loud on a place like YouTube. And if you've got the algorithms helping you, then you'll see more of that. Sometimes you think, okay, maybe it's 50-50, maybe it's 60-40. It's not. So it's very difficult to know from social media just how to weigh the evidence. So this is stuff that we need to think about when we look for evidence and when we go on social media. So we need to ask the right questions, and we need to look for confirmation and disconfirmation, but then we also need to know how to weigh the evidence. And I'm going to talk a little bit about that later on. So confirmation bias, and this is completely true also for scientists, which is amazing, is that we also, when we do all kinds of things in science, when we try to write a paper, we look for stuff that convinces the reviewers and convinces us that we are right, when many, many times we could be very, very wrong. So we need to know about this bias, and we need to be able to compensate for it and overcome this. So did you read my paper on confirmation bias? Yes, but it only proved what I already knew. So actually, one of the things that I wanted to do is that it's great that somebody in the 1970s ran the Watson task and told me that there's confirmation bias. But is there really confirmation bias? How would I know? That's why I run replications. So since I came to HKU with students in this class and other classes, we ran replications using the best standards, the highest evidence of open science in order to run replications with a large representative sample. Therefore, this means that we're doing an independent, well-powered, pre-registered replication of a classic finding in order to know, was this something anecdotal in some conference in the 1970s, or does this really hold for a representative population right now in the years 2020? Yeah? So I'm going to show you our evidence for confirmation bias. So this is me with Shochi. And we ran this. So this specific paper was by Jonas et al., 2001. And what they tried to show is that if you present evidence in different kinds of ways, then it affects confirmation bias. Actually, our application was not completely successful in that the type of presentation mode did not affect confirmation bias. However, very interestingly, we gave people the ability to search for more information that confirms their hypothesis or their worldviews, compared to disconfirms their worldviews. And across all of these here under the red, you can see that there's actually supporting information versus conflicting information. So here, there's a lot of evidence for confirmation bias. So here's the difference. Any difference beyond zero, so if everything is positive, there is confirmation bias. And you can see that the numbers here are well above zero. So actually, we find, regardless of what the presentation mode is, we find that there's a lot of confirmation bias. People just search for information that confirms their worldviews. So this is not me just reading the evidence and saying, oh yeah, somebody did something in the 1970s, therefore true. But instead, I go with HKU students. This was a thesis, and they run the replication with me on a representative sample. So in this case, half successful in showing there is confirmation bias, unsuccessful in presentation mode did not change confirmation bias because confirmation bias was so strong, regardless of whether this was in sequential or simultaneous. Right? So it's always interesting when I see a classic finding from the 1970s, in this case from the 2000s, I want to know whether this holds or not, so I run this together with my students. Okay? So I'm going to show you lots of examples for that. This is Dorothy Bishop. She just retired last year, so she is an emeritus from the University of Oxford. So a very accomplished scientist. I think we all aspire to be this kind of impact. So perhaps we talked about this before. I'll just give you a quick reminder. When you go on Google Scholar, when you look me up or your professor or any scholar, you want to know how impactful are they, there's this thing here on the side. And it gives you kind of like a measure of how engaged they are with the scientific community. How to read this? Do you know how to read this? So number of citations, very clear. So Dorothy Bishop, I think the slide is like from 2 years ago, 3 years ago. So I already had 66,000 citations. Go and look at Daniel Kahneman and Amos Tversky. Wow, big number of citations. Typically, Nobel Prize winners have big impact, especially after they win the Nobel Prize, the number of citations goes up. So sometimes citations could be bad citations. People say, oh, this completely doesn't make sense. So we're going to talk about all kinds of evidence. So for example, somebody who says that people can predict the future. He gets a lot of citations, but he gets bad citations for this is an example of science that should not happen, right? But in case of Dorothy Bishop, she really cares about credibility and rigor. What are the other two numbers? So you've got the H index and the I index. Do you know what these mean? So I10 is easier to explain. I10 means that she has 383 publications that have more than 10 citations. If 10 sounds like a small number, it is not. Sometimes getting attention from the scientific community is hard. Many of us publish papers that maybe 3-5 people will ever read because our topic is so narrow. I just happen to be in a field that has a lot of impact on many different fields. Therefore, we get a little bit more citations. She does some very interesting research. We're going to show a little bit on twin studies, what happens. So how much is genetic and how much is, so nature, nurture, very impactful kind of stuff. So she gets noticed out and she's very prolific. So she has more than 380 publications with 10 citations. What is this third one in the middle, H index? And H index means that she has 134 publications with 134 citations. It's very interesting. So if this was 50, then it means they have more than 50 publications with 50 citations. So actually, increasing on the H index number is very difficult. Not a lot of people get to high numbers. So this is considered to be a high number. So what this shows is not necessarily the quality of the researcher, although in this case, I do believe that Dorothy is a very high quality researcher and believes in open science and credibility. But it does show that the academic community cares and pays attention to her. So in the past decade, she started going around conferences and talking to people about cognitive biases in research and researchers. One of the reasons why I deal with this topic and why I give workshops on this and why I research this kind of thing is because of Dorothy. So you can see in 2020, it had the psychology of experimental psychologists overcoming cognitive constraints to improve research. And you would think 2020, surely somebody talked about this before. If Daniel Kahneman and Amos Tversky talked about this in the 1970s, 1971, then surely in the past 50 years, we've done something. Turns out that we haven't. And I'm going to show you some case studies about how much we haven't done in the past 50 years. So you need somebody like Dorothy Bishop to go back 50 years and say, you really need to pay attention. You're telling the world how to overcome their biases, but you are very, very biased. So we learn something from her. She is the one who introduced this to us. Now, why would I mention her to you? Because of this very interesting video that came out. So Dorothy Bishop talks about confirmation bias. So she was doing a meta-analysis. And a meta-analysis is a systematic review. Whenever we want to know whether there's something holds or not, then we want to look at the entire literature, the stuff that is published and the stuff that is not published. We try to do this as systematic as possible. So we write to others on forums saying, have you done any research on this? Even if it's unpublished, can you send this to me? Now here, she was looking for all kinds of difference between two kinds of twins. And she was convinced that there is evidence for that. And everything that she searched for showed support for that. However, when she sent this out to review and when she was getting some feedback, suddenly she realized that there was another piece of evidence that does not show any difference between those. So you can see here the difference between the two types of twins, the MZ and the DZ, is actually non-existent, so 0.33 and 0.36. And what was interesting about this is that this is research that was conducted by her PhD student. So she knew about this long time ago. But somehow, because of confirmation bias, she completely deleted this from her memory. So confirmation bias also works in a way of reframing, rebuilding our memory in order to just remember the stuff that we want to remember. So even if we heard some disconfirming evidence, we completely let it go. So this is why peer review and opening this up to the public is very important, because other people might remember something that you've neglected to find, or that you found, or even did with your PhD student that you completely forgot about, right? So we need to know all these null effects in order to have a solid meta-analysis. Charming person, does great work, and now she is fighting the good fight against paper mills. Paper mills is a big problem. There's lots of fake journals out there, and there's lots of fake scientists with a lot of artificial intelligence submitting to journals, pretending to be credible evidence. So she's fighting the good fight to try and bring them down. This is her new crusade once she retired. So she does a lot of very interesting research on that. So later we'll have a tutorial video to kind of guide you to how to do good search on Google Scholar. But even then, you need to be very careful what results you look at. Don't just cherry pick, don't just look at the stuff that may support what it is that you think is true, but try to also look at the others that disconfirm and shed some doubt on the thing. So, I've heard some rhetoric from both sides, time to do my own research. So every time I hear somebody saying, scientific evidence is about doing your own research, but then we don't know how to do our own research, because the first thing that comes up, or the first thing that confirms our hypothesis or our worldviews, it's like jackpot. Now we can stop. We found evidence for what is it that we were looking for. So we have a lot of these memes. So for example, a new study released. Does this study validate my preconceived belief? Yes, must be a good study. I was right all along. I am a genius. If it doesn't, then it must be a bad study. Find any flaws? Yep, bad study. I was a genius. I was right all along, right? So cherry picking, confirmation bias, is a very strong cognitive bias that we've known about since the 1970s, but we still fall trap into. So if Dorothy Bishop, the person who warned the world once again in 2020 that you need to worry about cognitive biases, admits that she forgot about disconfirming evidence from her PhD student, if Dorothy Bishop falls into the trap, then we can all fall into this trap. So we need to be very careful in how we do search and how we look for evidence. So what's the takeaway from this? So we tend to trust all kinds of citations that support our view, but it could very well be that there are citations out there with solid evidence that does not support our view. So we need to look for both sides. We tend to cite only supportive material. So sometimes when we write the introduction, when we say, yeah, of course, this supports. Sometimes we write the introduction after we already have the evidence. So we look at the evidence afterwards and say, okay, this is what I found. I'm just going to find the right citations to put in the intro in order to convince everybody else that I was right. But there's a big problem with that. We sometimes need to look for the alternative evidence, right? Sometimes we think that if we're going to read the literature, then it's, we're going to be unbiased, but it doesn't necessarily help, as you can see with Dorothy Bishop. So we need to really overcome all of these things. So the way to do this is open everything up, to conduct peer review by experts, right? And then to have pre-registration, which means scientific criteria on how we're going to conduct the search. So even meta-analysis, even systematic reviews, if you go on my website, there's a whole page dedicated to that. So I'm part of a group that says that even meta-analyses need pre-registration. And we need to submit the pre-registration to peer review before we conduct the search and the study. Because even meta-analyses can be very biased. So just finding a meta-analysis does not necessarily mean that this is the best evidence that we have. And I'm going to show you some examples, not this week, but in following weeks on that. Openness, transparency, invite criticism, document and track weaknesses, and so forth. Now, Veritasium, amazing case study. I want to share with you this kind of debate that he had with a UCLA physics professor. So Veritasium invites criticism. I really appreciate him for that. He really wants to learn. He really wants to get into the truth. So he posted about something that seems too good to be true, for sure. So basically what he was showing is that there is the ability to have a car that runs on wind with no alternative source of energy that is able to run faster than the wind that's pushing it. Physics professor sees this on YouTube, and a lot of people in the academic community follow Veritasium. And he's like, come on, man. I'm a physics professor. What you just showed is impossible. Now, the interesting thing about Veritasium is that he's really open to criticism. So they had a lot of back and forth. And finally, they decided on something exceptional. And the exceptional thing is, a physics professor bet me $10,000 I'm wrong. They bet on this. They put real money into it. Who is going to be right? Is it the physics professor from UCLA or is it Veritasium? An amazing case study.
I am here to sign a document betting $10,000 that my last video is in fact correct. This is the video in question.
Before I show you the video, fascinating stuff, I want you to pay attention to the details. So what does Veritasium do that we as scientists don't do? What is the right approach? What is the wrong approach? Look at what Veritasium is doing and look at what the professor is doing. And I'm going to ask you for your opinion. What is confirming evidence? What is disconfirming evidence? Okay? So now that you know about confirmation bias, I want you to look at the two sides here and tell me how best to get to the truth. Okay?
Some people may have missed it, but in this car there is no motor, no batteries, no energy source besides the wind itself. And the counterintuitive claim is that this car can maintain speeds faster than the wind that's pushing it. There is a physics professor at UCLA who got in touch to say that he thought that I was wrong, that the explanation was wrong. You know, we went back and forth a little bit, and eventually I said, well, how about we bet $10,000? I can prove it to you, this vehicle really can go downwind faster than the wind. And to my surprise, he is taking me up on the bet.
Look, no one is perfect, but you have a much lower error rate than most people in YouTube space.
Now, Professor Alex Kosenko wanted this wager and all related discourse to be public. In fact, he suggested we get a celebrity to witness the signing. So I asked Neil deGrasse Tyson, Bill Nye, and Sean.
You know these two? Big celebrities in science. Yeah, you know them? Yeah. To get them into being observers about this, doing the peer review is amazing.
Carroll to be our witnesses, and they graciously agreed.
And Alex, I just want to say, I agree with everything you said about Veritasium, that generally I can watch it and not have to wonder, is he going to mess up? How am I?
No, he's brilliant. He's brilliant.
I'm excited about this bet because if I am wrong, then I want to know. Like, the whole point of the channel is to get to the truth, and that is, I think, why we're all here today. And I think, you know, this is a great chance to sort of see. I'm going to summarize Alex's main points in this video, but I'll put his full presentation here.
So let me first explain what I see in the video. In the video, the vehicle is operated in a gusty wind. Initially, you have the wind speed exceeding the car speed, but then the wind speed is not constant. The wind speed drops, and the car moves by inertia with deceleration for a while.
So basically, Alex thinks a gust pushes the car to a high speed, and then when the wind dies, the car is going faster than the wind momentarily, but it must be slowing down.
In fact, that will be my conclusion at the end of this presentation, that whenever you have velocity faster than the wind, I'll actually show you in an equation, the acceleration is negative. Okay? The second effect is that the wind in the video is measured at the height of about a meter or meter and a half, but the propeller goes to some 3 meters above the ground.
Now, due to interactions with the ground, there is a wind gradient. Wind travels slower, close to the ground, and then faster higher up. Now, Alex estimated that the wind speed at the propeller might be 10 or 15% higher than at the telltale. So it's possible that the car could be moving slower than the wind at the propeller, and yet appear to be moving faster than the wind at the height of the telltale.
Now, I think that this is a small effect. However, in combination with the previous effect, it just can make this more frequent. Okay, and that completes.
If I remember the video correctly, Derek reports that they've achieved up to 2.8 times wind speed. That feels much higher than what is possible here, unless the wind had picked up and then spontaneously sort of dropped.
Very, very good question. Okay, if you're going for the record, you probably will do many attempts. You will be sampling that gusty wind over and over and over until you set the record, right? That's how you set the record. And on one of those occasions, you will get a nice strong gust, which is 3 times the ebb that comes after it, okay? And that's when you will clock the record, and that's where that 2.8 factor will come in.
So what about the treadmill tests? These are conducted in still air. By moving the ground backwards, you're simulating a perfectly steady tailwind. And if you hold the car stationary on the treadmill, well, that's equivalent to the car going exactly wind speed. Now, if the car can move forward on the treadmill, that shows it can accelerate faster than the wind. But Alex had multiple explanations why these experiments don't actually show what they claim to show.
If you have this fluctuating speed of the treadmill, and then if a human just sort of steers it, it then can introduce unconsciously a bias towards the desired result.
So would it be that the guy with the spork is inducing the model craft to go across the wind now and then.
So
as you pointed out, Alexander, it's going downhill now and then.
Yeah, I'm 100% sure that the guy in the video doesn't do it on purpose. Okay?
Yeah.
However,
by the way, anytime that there's somebody who tells you there's 100% sure on anything, you should be a little bit skeptical of this person. Just a side note.
Yeah, if he's expecting forward drift.
Yeah, it's classic.
Right? Yeah, absolutely. Yeah, that's what exactly. Okay, so you got it.
In the absence of convincing experimental evidence, Alex turned to theoretical analyses, like one by MIT Aero professor.
So this goes on and on. Obviously, the UCLA professor really knows his stuff, both on the empirical side and on the theoretical side, which obviously is a big professor in an Ivy League university. He knows his stuff. More than that, he can explain why actually Veritasium found an effect. Why did he find an effect? Because of unconscious bias. So people think that they're observing something, but actually what happens is that they're causing this. What are your impressions? What did you see? What did you notice on both sides? What are your impressions? What seems convincing, unconvincing, strength, weakness? What did you see? First, interesting debate, right? Even if you know nothing about physics, this is interesting. YouTube versus academia, right? I want to attend these matches anytime. Yeah, good stuff, right? Obviously, one of these sides has a lot more evidence, information, theory to support, right? So there's a difference in reputation. What do we know about the two reputations? Which one would you go for? UCLA versus YouTube? Right. What is it that creates the UCLA reputation? How did we come to decide that UCLA deserves the reputation? Academic research?
Like Edison out or whatever.
Yes. Yeah. So UCLA, an academic institute of the higher standards of academia, right? We associate this with scientific evidence, and we tend to believe that these people know exactly what they're talking about. YouTubers, depends on who the YouTuber is, what background they have. We don't know much about Veritasium. Maybe he was also a UCLA professor. We don't really know. Maybe we should check. But right now, we don't have any clue about this, so we need to make some adjustments, right? Some shortcuts, some heuristics. Our heuristics here are UCLA professor versus YouTube. It's not even a straight fight. One is obviously in a much better position. So I kind of felt sorry for Veritasium. So this was the summary video, but when this thing happened, it's like, losing $10,000 to academia is a bit sad, right? Anything else you noticed? How about the arguments by the professor? Even if you don't understand the physics behind it, what did you see over there? So obviously there's this thing about 100% sure, which is interesting. Sometimes we say things with a lot of confidence. I listen to a lot of podcasts, and it really bothers me every time. Like Hidden Brain, for example. I don't know if you listen to this very good psychology podcast. Like he says something, and then people respond, that's absolutely right. Absolutely, absolutely right. 100% right. Like there's nothing that's absolutely right. We don't know anything for sure about anything. There's like a very high probability. We're going to talk about confidence, how confident we are, overconfident, underconfident. We need to make some adjustments, but absolutely right for every other statement. We need to make some adjustment. Aside from that, what else did you see? Yeah, he cares about the evidence, and he came prepared, right? So he addressed each and every pieces of evidence that were presented to him, right? What was it about his explanations? What did you see about the explanation? Yeah, it's difficult to judge, right? We don't really know anything about that. But from the way that he explained it, it seemed like the two peer reviewers, famous celebrities that know science, seems like the stuff that he was talking about sounded convincing to them, right? It's not even only that, but at some point, these peer reviewers starting making the arguments for him. This is, yeah, you're right. This is exactly what's happening. So you got the point, right? Yeah. So it's not only that we have Alex, actually we have two external observers, which is very, very important. This is why in academia, and the reason why people think that academia is better than YouTube is because we have peer review. And we get people sometimes of very high caliber, like here, who really know their stuff and communicate science to the public, but also have degrees to come and judge. So it's not just Alex. It also seems like from this kind of interaction that the peer reviewers, the external expert, buy into this, right? So very interesting. Yeah. So if you haven't looked at the slides, what's the outcome of this? What turned out at the end? Very interesting conclusion to this. So this is a public bet, science celebrity observers done at the very highest. I actually would really like it if we resolved in academia, we would resolve debate this way. So we would make it completely public. We would invite peer reviewers to come and address. We would, in front of the world, I think this one has 16 million views. In front of 16 million people, we would argue each side, and then we would put our money. So for example, if I'm convinced, absolutely right. If I'm convinced, I'm willing to put $10,000 behind it. We never do this in academia. It's amazing that they did this here. But this statement is what I really care about. Because when I say this kind of thing, it's not taken for granted that in academia we live up to this. What I like about this is that him saying, because if I'm wrong, then I want to know. So there is some humility here. I think what bothered me a little bit in the exchange between Alex and Veritasium is that Alex just seemed at the beginning is like, oh, I'm going to get $10,000. This guy. So he's preaching. He's telling Veritasium all the reasons why he is wrong, but there's no humility. So one thing, at least Daniel Kahneman had a lot of humility, and he was always open to the possibility that he's wrong. Alex does not seem open to the possibility that he's wrong. He's so sure, almost like a gambler's fallacy. I'm going to win this. I just know that I'm going to win this. Do you really know? The odds are not exactly 100% zero. So like the whole point of his channel, and the reason why I like Veritasium, is that he wants to get to the truth. Another interesting aspect about this is Alex actually explains unconscious bias. So he's saying people are causing this. So I'm absolutely 100% sure that the guy in the video doesn't do this on purpose. So he's not saying you YouTubers are fooling the world. It's first he's saying you YouTubers are fooling yourselves. Okay? Finally, what is the conclusion? The UCLA professor was wrong. Absolutely wrong. And actually, it's very easy to demonstrate that he is wrong. The only thing that the UCLA professor needed to do is just try and replicate. Just run the same thing again. What she's doing here, the UCLA professor can do. So I'm just going to show you the YouTuber took another YouTuber, and together they built a model. And now this model is uploaded. Anybody with a 3D printing machine can print this for $2 US. This is something that the UCLA professors with tons of funding could have done in maybe an hour, right? Instead of going ahead and betting $10,000, let's spend an hour, sit down and try to replicate this and see what happens. So here's the proof.
Does it work?
It totally works.
Amazing.
Oh my god, it's so good.
Her fourth version of the cart works spectacularly, and it was designed to be replicated by anyone using just a 3D printer and a simple list of materials. She explains how to build it with more details on the engineering process on a video over on her channel, so go check it out. Now, Professor Kosenko has now conceded the bet, and he transferred $10,000 to me. So I want to thank him for being a man of honor and changing his mind in light of the evidence I presented, which is really not easy to do, especially in a public debate like this one. Now, I do not want to keep the money. I want to invest it in science communication. So
yeah, good on him. $10,000, you can go and do some shopping, but he has reinvested this in order to get science to be a better kind of science. So I appreciate a lot of things about this, but don't you think this is an amazing case study? Like seeing this unfold in real time was unbelievable. Until now, I still have like emotional reactions to discovering that Alex was wrong. Mind-blowing stuff. I have more stuff like this, but I'll give you 5 minutes break, come back, refresh yourself, and we'll continue. Okay, good. So our takeaways, the lessons from this amazing, remarkable case study is that in order to do good science, we need to let go of all sorts of heuristics. For example, UCLA academia, reputation, therefore academic evidence. So whenever we see UCLA versus YouTuber, just like, of course, UCLA. Not necessarily. Sometimes people, and I see this, when I submit a paper to journals, sometimes we immediately get the reaction just because they see Chinese names or Israeli names or HKU or something that is affiliated with Hong Kong or China. They immediately perceive this to be lower quality. So even when I have collaborators who are native English speakers, and they're the ones who wrote the manuscript, immediately we get a response saying, please spell check, proofread this with a native speaker, just because they see our names coming from Hong Kong, which is like amazing. There's all sorts of evidence for this kind of bias. So HKU is no less than UCLA. Sometimes being a YouTuber does not necessarily mean that you don't know anything about academic evidence. It is about showing experience and reputation with real evidence, just like Veritasium. So the kind of standards that you uphold. So we really care about overcoming bias. We need external, trustworthy peer reviewers and experts in order to open things up publicly to evaluate the kind of work that we do. Open science is very important to me, and I try to ensure this. That everything is done in the highest standards of evidence. So one of the things that we'll learn in this course is how to evaluate evidence and how to overcome misinformation. And then doing independent replications. Come on, man, you can not have to go into bets of $10,000 if you can just replicate this $5 with a 3D printer and use some of your funding at UCLA in order to just check this. Instead of using all the fancy theory and all the equations, just give it a go and see if it works. Maybe you can learn something. So look for this confirming evidence. Yeah. Have you watched this movie, Oppenheimer? Yeah? Great movie, really great movie. Even though I know the story about Oppenheimer and what happened with the Manhattan Project and the creation of the nuclear bomb, still I was on the edge of the seat the entire time. And this is not a short movie. And what was nice about this, and this is a tweet that I took from Daniel Lakens. Daniel Lakens is a very important person in the open science community, has amazing courses about credibility, and he'll be mentioned quite a bit. He captured a moment that I felt. So here, love the scene where we learn that the results of the new experiment and one person runs off to replicate the findings. Then Oppenheimer calculates it's theoretically impossible. So Oppenheimer says, this is never going to work. This is absolutely, these Russians, probably false. And then the person from the other lab that went to replicate this comes in and says, yeah, but we successfully replicated this. So sometimes your theory and your numbers in your articles and your knowledge does not necessarily mean that this doesn't work. Sometimes all it takes is for somebody to run to the other lab and try to replicate this. So even Oppenheimer, amazing movie. If you haven't watched it, look out for that scene. So my takeaways, all kinds of biases here. So we'll just go through this very quickly. The professor could have tried this himself for petty cash. Why not replicate? So for me, this is a combination of hubris. Like, how much of an ego do you have to just go straight on with 16 million audience in order to combat a YouTuber before you even tried this kind of thing? Why did you not replicate this? And there's a bias against replication. Just do the work. The professor assumes unconscious bias in the people with a pen. But did you take a moment to consider that maybe you're biased and you have unconscious bias? So blaming others for bias is very, very easy, but take a moment to look at yourself so it doesn't contemplate this. And we're going to talk about bias blind spot. And then the professor finds evidence to support own theory, but rejects and overlooks every evidence that rejects his own theory. So this is confirmation bias. So this is a remarkable case of confirmation bias, and we can see this all over throughout. Chris Chambers, one of the leading thinkers in open science, came out with a book in 2015, The 7 Deadly Sins of Psychology. And the first chapter, which is made available to you, so you'll have a link in order to go and read this, is outcome bias, confirmation bias, publication bias, hindsight bias. So you've learned about outcome bias and hindsight bias in the sheets of papers that I gave to you. Confirmation bias is what we just learned about. What is publication bias? Have you heard of publication bias? Publication bias is this
people who didn't publish and decide what gets published or not. They just publish what seems interesting, eye-catching, making a big statement, not like the objective proof.
Yes, exactly. So when we evaluate in peer review and when we publish in papers, in journals, so when we have an editor and the editor's role is to evaluate whether this should be published in a journal, we have publication bias going for the catchy, sexy, trendy, right? And often the stuff that's trendy, sexy, is the stuff that finds support, evidence for something. But when we don't find support for something, it's not interesting. We don't want to know about this. Why is this a problem? If we have 100 trials of a COVID vaccine, but only 2 of them worked, as fluke, randomness of the universe, 2 out of 100 work. If we submit all 100 to the journals, they look at the 98 that didn't work and say, it's not interesting. There's nothing there. They didn't find anything. Let's reject. Let's just publish the 2 that worked because it's sexy, trendy. Now we can show that there's a COVID vaccine. But us as audiences, as people who want credible scientific evidence, we want to know all the 100, right? Now, the problem, even worse with publication bias, is that after a while, we, academics, we understand this. And then we say, why even submit the 98? We know it's going to be rejected. So what do? We open the file drawer and put this in the file drawer. And we only submit the 2 that worked. Now, before we take a COVID vaccine, we want to know what are the 100 trials. So everything needs to be open. Publication bias is a very, very big bias. So Chris Chambers was one of the first to suggest something called a registered report. In a registered report, we submit the plan to the journal. We all agree together that this is the best plan. So Pfizer, Moderna, when they do this kind of thing, they need to register the trials in a public place, time-stamped, where everybody agrees together that this is the best plan, and only then they run the trial. And whatever the result of the trial is, it must be published. So medicine does this very well. Social sciences does not do this very well. Physics, biology, chemistry, economics does not do this very well. So we came up, Chris Chambers was the first to suggest and run this, something called a registered report, where we agree on the plan together, and then we publish the results no matter what. Support, sexy, trendy, p-value lower than 0.05 or higher than, doesn't matter. All this gets published because we want to know about the 100, not just about the 2 that worked. So publication bias is a very, very big problem. Okay. Very, very quickly, let's get, why not? We can do this. So we'll go to the next one. Some questions for you to ask about yourself and your classmate. So as you're answering this, please think, so what is the research question? What is it trying to do? What is this going to show? What would most people respond in this kind of situation? So what I'm asking you here is to rate yourself relative to the average classmate about dependability, being able to be counted on or relied upon, objectivity, how objective you are, how considerate you are of others. Are you a snob, more of a snob, less of a snob than others? Are you more or less deceptive than others? Are you more or less selfish than others? So others, we can talk about our classmates here, of all the people in the class, right? So take a moment. I'm going to put this back up. So if you need to scan this again, you can scan this again. Yeah, so I'll give you a moment. As you're answering this, contemplate, so what does this show? So this is a classic experiment, has been run many, many times. What does this experiment show? Terrific. So what do we see here? What do you notice? What would be the hypothesis? Good. So what positives do you see here? Good. So here you expect people to rate themselves as higher. How about the other ones? Probably lower. Good. Do you know what this is called? What is this a demonstration of? What's the name of this? This is yeah, there's definitely some of that in there. Yes. It's been named, there's many names to this. So there's definitely social desirability here, and people want to present themselves as being better than what they might actually be. But that's it, that we actually believe the people. This is what they think about themselves. So they don't want me to think that they're great. Maybe they also think that they're great. But what's interesting about this is that people generally perceive themselves to be better than others. And this is called the better than average effect. Now, what's interesting about the better than average effect is that better than average effect also holds true for people think that they're less biased than others. So better than average extends to also how much of a cognitive bias we think we have compared to other people. So we can see the results here. So generally, less biased than some of the other classes, so you're definitely anticipating some of the stuff in advance, but we can see that there's a difference between the top 3 and the lower 3. This is a little bit closer, but you can see a difference here. We're not a big class, so the sample size is not very large, but we can already see a kind of a pattern here, right? So hold this in mind, and this is the first demonstration of classic finding in judgment decision-making. This is the first article that Kahneman and Tversky ever published. So here's a case study. And in this case study, this is a very typical article. Suppose that you have run an experiment on 20 subjects and have obtained a significant result. So maybe some of you don't really have not gone through a lot of statistics, especially if you're only second year. That's completely okay. But we have this elusive notion of a p-value. And if p-value is lower than 0.05, we consider this to be a rejection of the null hypothesis, therefore concluding some support that it's unlikely, if the null is true, it's unlikely that we'll observe this kind of evidence, and have obtained a significant result which confirms your theory. You now have cause to run an additional group of 10 subjects. What do you think the probability is that these results will be significant? So if there's a published finding in the literature, then what do you think the likelihood is going to be if you run this again with 10 more participants? If the sample size seems a little bit small to you, that's okay. Back in the 1970s, this was considered to be very, very typical in social psychology. But if we put social psychology aside, I still have colleagues in the neuroscience, in developmental, where they need to bring in babies. So we still have places where it's very difficult to put people in scanner. It's very costly. So we still have sample size of something like 20 in each condition because we don't have a lot of resources. So think about this. What do you think the likelihood is? Now, what's interesting, and I'm going to just very briefly tell you about this, there is an entire literature on priming, what we call social priming, that has shown these kinds of effects. So when we have, so a lot of the priming studies look a little bit like this. They run 20 in each condition, and then they observe some effect. One of the classic social priming studies is that back in the 1990s, John Varge has observed that if we get people to unscramble sentences that have to do with the elderly, compared to unscramble sentences that have to do with nothing, like chairs and walls, then people who are observed or have activated the notion of elderly, when you measure them walking from the entrance to the lab to the elevator, they walk slower. This is social priming. So unscrambling sentences, activating a mindset, therefore leading to all kinds of effects. Many of them are with this kind of evidence. Now, we've done a lot of replications. What we call register reports that I told you with Chris Chambers, we've done a lot of replication register reports, not with one lab. We ran this with many labs around the world, 20 labs, some of them are 40 labs. And again, some of them we ran twice. Again and again, we cannot find support for social priming. Unscrambled sentence, recall, contemplation, hostility, commitment, honesty, intent. We tried many, many times in the last decade to replicate these findings. Go and look at a book, social psychology book, a judgment decision book. Many of these studies are written in your books as solid evidence. But when we run these replications, we fail to find support for this, not in one lab, in 20 labs, 40 labs. So again and again, we've tried many, many times. We can't find support for this. Why am I telling you this? First of all, not everything that is in the social psychology judgment decision-making book for undergraduates is solid. So we need to evaluate this. When first I came into HKU and they gave me this book and they said, can you teach this? I flipped through it and I saw that every other page, there's a finding that I already know does not replicate. I said, I'm not going to teach this. I'm going to run replications with the students in order for us to validate what is real and what is not. Now, the interesting thing about this is that Daniel Kahneman, who used the first scenario that I just showed you. So this is actually from the first study. So Daniel Kahneman went around in statistician conferences, gave this to people and said, what do you think the probability is? And showed the statisticians get this wrong. So he warned the world about the problem of believing in small samples, that you cannot look at this and say that this is solid evidence. So replicability is expected to be very, very low. Now, what was interesting is that in the year 2011, this book came out, Thinking Fast and Slow. When I was listening to this as an audiobook for the first time, I think it was 2016, when I came to that chapter, I had to pause my run and sit aside and listen very, very carefully, because this is what Daniel Kahneman wrote about social priming that I know does not replicate very well. Now, I have the benefit of hindsight because he wrote this before we did the replications. But in 2016, I already knew the results of a lot of replication studies. This is what he wrote. So the marvels of priming. So a lot of interesting things about priming. The idea you should focus on, however, is that this belief is not an option. You have to believe in social priming. The results are not made up, nor are they statistical flukes. You have no choice but to accept that the major conclusions of these studies are true. More important, you have to accept that they are true about you. Now, this was a little bit embarrassing for Daniel Kahneman, and he already realized in 2012, when the first replications came out, that he wrote an entire chapter where he advocated for social priming. So he wrote an email in 2012 to all the social priming people saying, you really need to check yourself. All I have personally at stake is that I recently wrote a book that emphasizes priming research. Count me in as a general believer. But you should check yourself because I see a train wreck looming. And then lots of headlines, Nobel laureate challenges psychologists to clean up their act, which is very, very important. So a year later, he already was getting worried about this chapter that he wrote. 5 years later, so this is already 2017, somebody did an analysis, a statistical analysis of all the findings in that chapter, and he found that this chapter is a disaster because most of the finding in that chapter, and Thinking Fast and Slow, the bestseller of all times of social psychology, judgment decision-making, things do not hold. So an analysis showing that this chapter is a disaster. So Daniel Kahneman, already very close to 80 years old, I think even more than 80, more than 80, goes on a blog, somebody's blog, and then he writes this comment, and he writes, as pointed out in the blog and earlier by Andrew Gelman, who's a famous statistician, what the blog gets absolutely right is that I place too much faith in underpowered studies. Underpowered means that the sample is too small. There's a special irony in my mistake because the first paper that Amos Tversky and I published was about the belief in the law of small numbers, which allows researchers to trust the results of underpowered studies with unreasonably small samples. So our article was written in 1969, published in 1971, but I, the father of judgment decision-making, failed to internalize its message. So he's the person who warned the world in 1970 about the fallacy of statisticians getting statistics wrong, but then he's the one who fell into it with social priming. So a remarkable case study. And you can see his paper cited more than 4,000 times. So a very well-cited paper. Nothing gets cited 4,000 times in JDM and social psychology unless it's Kahneman and Tversky. So a very good study. Plus, I ran this with an undergraduate thesis student. We ran a registered report. So we submitted to peer review the plan that we had to replicate Daniel Kahneman's study, and we found exactly the same things. So we showed that people tend to fall into the trap of believing underpowered studies. So we were able to successfully replicate something that was done 50 years ago. Right? So before I even trust what Daniel Kahneman does in 4,000 citations, I want to make sure. So I run this as a registered report with my students. So you can see the recommendation and everything is done very publicly, open peer review. So he contemplates on this and he's saying, I was wrong, at least in this case. And then he contemplates on there were essentially no takers from our suggestion on priming research should be proactively replicate each other's work. So I really like this. One of the biggest figures in psychology and behavioral economics contemplates about priming. But what bothered me a little bit is, and I had questions to Kahneman, I was asking Kahneman, you called priming researchers to proactively replicate each other, but who is going to replicate judgment and decision-making? So who's going to do all this for judgment decision-making? So for me, this is also a little bit of bias blind spot. You see the bias in others, social priming, oh, they need to check themselves. But Daniel Kahneman did not call or conduct a lot of replications of his work. So who did this? We did this. So we've conducted, me and the students at HKU, we've conducted 150 replications of judgment and decision-making, including Tversky and Kahneman. So to me, this is a representation of bias blind spot. So one of the first replications that we did was on bias blind spot. So this is in 2019. Good news for science, bad news for humanity, bias blind spot just replicated. And here you can see all the Cantonese, Chinese names of all the students that attended my class. So basically we submitted this together to a journal and we got this published in a good journal that just happens to be called Judgment and Decision Making. So that's nice. This is the results of the bias blind spot, the kind of thing that I just gave to you. So this is our Mentimeter. And this is surprisingly similar. Oh my gosh, it's, yeah, a little bit lower in the effects, but very, very similar. So you can see we've successfully replicated in a small sample, but the stuff that I ran in a bigger class in 2021. So we can see the above average effect again and again. But what's interesting is that in 2021, after I showed people that they have the better than average effect, I asked them, how biased are you? And people still rated themselves as being less biased than others. So it's something that happens. It happens to us. It happens to Dorothy Bishop. It happens to Daniel Kahneman, the person who warned the world about things like that. Plus, we've done replications of better than average effect. So for example, here, our results indicate that the majority of participants rated their driving skills and safety as above average. And then with a thesis student, one of the first thesis students that I had at HKU, Psychology Today summarized our replication and published in a good journal in 2021. So she found better than average effect. This is a seminal finding about hindsight bias. So basically what it means is that whatever the outcome is, once you see the outcome, you find it to be less surprising. So once we see the outcome, we cannot undo this. The outcome influences the way that we perceive how surprising and the likelihood that this is going to replicate. And the second one is outcome bias that you read about. Also very impactful people, that whether you see a positive or a negative as the outcome affects your evaluation of the decision that was made. But you're not supposed to look at outcomes. It's not supposed to influence you. So it's very, very interesting that sometimes we can demonstrate hindsight bias on the replicability of hindsight bias research and outcome bias on the replicability of hindsight bias research. And we even published this. So we ran this with a well-powered study with a big sample, and we pre-registered this. And in the third study, after we did a replication with all these undergraduates in HKU, so after we did a replication of Fishoff and a replication of another one by Fishoff, so we showed hindsight bias 2 times with 2 different articles. We also ran the third study. We found strong support for hindsight bias regarding the perceived likelihood of a replication of hindsight bias. So even when we told people, we showed people, it's written in the sheet of paper what outcome bias is and what hindsight bias is, people are unable to compensate for this. So even Daniel Kahneman, who warns the world about cognitive biases, is still biased. Even when you tell people about bias blind spot, they still exhibit bias blind spot. Even when you tell people about outcome bias and hindsight bias, they still have outcome bias and hindsight bias. So when you go over the tutorial of how to search for information, always think about confirmation bias, outcome bias, hindsight bias, publication bias. So your first task is to take one of these biases contemplate this, see where this exists, and help us to overcome this. Okay? So this session is just a little bit of a teaser in order to show you some of the cognitive biases that are inherent in the way that we evaluate evidence. I know it's a little bit fast. We'll revamp. We'll go over this again at the beginning of the other session. If you have any questions about any of what happened here today, then you're free to contact me on Zulip and I'll explain a little bit more.